Like you can expect something like this, right? So we know if you read carefully, this is just a sketch, so it doesn't have to be fancy, right? But we know that we're up on a cliff. This is happening. We're not landing on the ground. Read carefully, right? We're not landing. We know that actually this point right here is something one. We can't figure it out just yet. But we do know that we're starting at time zero. We're at a height of 35. Make this for yourself right away. This is going to be just to find that other point across from it. Guys, sometimes I give you this point. You have to find the vertex, right? So don't always think times 2 times 2 times 2, right? No. It's sometimes divided by 2. So you got to watch out for how it's worded. I can't do every scenario, right? I know I'm going to come back to a height of 35. I'm actually given the vertex, which is time first, right? Time and then height second. You multiply this by 2, which gives you 3.5. This is going to be worth a full mark, right? That point, getting that one. I would strongly recommend, I don't know about you, I would strongly recommend quickly plugging these points in to a small little chart because it sticks out. If you ever make a mistake downstream, you can go back and be like, oh yeah, it doesn't make sense, right? Like it doesn't make sense. I made a mistake here. So stat, calc, let's say they didn't tell you quadratic regression, you should know already, right? It's motion of a projectile, quadratic, right? So just tell me that you're using quadratic, and that is, I have the key somewhere, but not on me, of course, right now. Can I just give me a second, okay? I want to actually go through this. You can look at your cat videos or something, dog videos. Is that still a thing? I don't know. Oops. So that is negative 14.694 x squared plus 51.429x plus 35. Okay, that kind of makes sense, right? 2 decimals is minimum, 3 is up to you, but I usually do more just so I can check if you rounded correctly. So that's your actual equation now. You graph it real quick. I need to turn on plot 1. What is all that mess in there, right? There you go. Let's clean that up. And oops, my window is not really good. So I'm going to go zoom 6 or zoom standard. Zoom standard is not bad. Y max is what? At least 100, right? Because my highest point is 80. That's good enough. So what is B asking? Determine the domain and range of the situation. I'm going to park that a little bit. I'm going to wait for some of those. The domain, my range goes from 1 to 80. That should be a given, right? We're not touching the ground, so the lowest is 1. The domain, we start at time 0, and this ends right here, okay? Right? Doesn't touch the ground, so we can't use the x-intercept. You know how x-intercept, you go y2 is equal to 0, second trace 5? What are we going to do now? y2 is equal to 1. There we go. y2 is equal to 1, second trace. Look at that. It's like a doctor's note, right? I'm okay with that. You do that. Second trace 5. Go over to the positive side, right? Remember, you can't use negatives in this case. And so that is 4.071. Okay, that's the point right there. So this is what I use for the maximum domain. That's when the story ends. Okay, so this is going to be worth, right, more because there's more work involved. Okay, let's keep going. C. How long does the arrow stay at or above 75 yards? Y2 is equal to 75. You know the drill here. And parabolas are easier because it doesn't do the cubic thing where it goes down and then back, right? It doesn't do the wave. So you just go y2 is equal to 75. Boom. You know what? I know this happens to some of you, and I would like you to know, right? If you graph that line and you don't see it on your screen, right? What's going on, right? That should be an indication, like maybe go check, maybe either Mr. Dirksen made a mistake here, gave me the wrong number, or you entered the wrong values, right, into your L1 and L2. So just be careful there. So I'm going to go second trace 5. I'm going to find the first intersection. So time 1 is 1.1667. No, second trace 5, sorry. Time 2 is 2.3333, right? So 4 decimals there. And then when it's a parabola, it's just delta time to subtract them, right? That's 1.17 seconds. Is that what you got? Okay. Boom, 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 right? That's my answer. D. How long does it say out of route 25? I did that on purpose, right? This one is actually easier. 25. Don't go get the negative, right? Don't get the negative. You're starting at 0. Let's do this. Time 1 is 0. Time 2 is Time 2 is 3.6847, right? So you're subtracting, so delta time is just 3.68 seconds, right? No need to subtract with 0, but really that's all is what you're doing. Omit negative, right? You would not be using the negative on the other side, right? And the negative time. Okay. Graph this scenario. You're really good at this. I don't see the need to. What is the highest we get to? 80. So 20, 40, 60, 80. Height in yards. And then time in seconds, right? And make sure you clearly indicate your time there. I go 1, 2, 3, 4, 5. That's good. I'm at 1 yard. This will be 10. So I'm right, like very close to the ground here. I'm at 35 here, and at 1.75, which is here, I'm at a height of 80. And then just make sure it's smooth, right? There. And the equation, like, right, it goes without saying, and boom, yeah, there's your graph. Okay, that's it. That's it, right? So be ready for stuff like that. Okay, homework. Okay, I was going to go over that. And it could be, maybe perhaps, very likely, that there might be something like that in the bonus section. Like something like on page 70, if you want to give that a try. But I won't give you the answers to that one. Let's go to page, was it 63 that I assigned? 63? I think it's basically the same thing. I see the 40 and 15 here. How many did it? You are going to get the bonus question right, probably. It's going to be a little bit more challenging than this, right? Like, so look at page 70, or what was it that I just showed you? Like those that have the boxes diagram there with the weird wording. If you want, that would I'll probably give you something like that for bonus. Okay. In terms of previous units, probability. So just know how to come up with probability, right? People sitting together or not sitting together, stuff like that, permutations, combinations, cards. Look up that kind of stuff for previous units. And I haven't finished it yet. I'm going to print it later today. I have something with design and measurement in there. finding the surface area of something, surface area volume, right? So basic stuff like that. Okay, let's go over this. So you have a cardboard that's 40 by 15. So you just make your cardboard, right? This is 40 and this is 15. Using a cubic regression, determine what sizes of squares should be removed in the four corners, right, to maximize the volume. So you're basically thinking, remember, these actually fluctuate. They can get bigger or smaller, right? But for all intents and purposes, we're just going to make those cutouts at the corner. And we usually call them X, like whatever you cut out. And we want to make a box that can fit the most in, right? And it's actually possible. So what we want to do here is we want to say, okay, there's a bunch of X's here. I know that if I were to fold everything up, right? If I fold the lips up, that X is really the height of the box. And that the width here would be 15 minus 2x. Right? That's the distance from here to here because I cut away an X on either side. And the length of the box, this here is 40 minus 2x. Okay? So I'm writing everything in terms of x. Okay? So the height is x, the width is 50 minus 2x, and the length is 40 minus 2x. Okay? So now that they're all in terms of x, all the dimensions, I can go ahead and create fill in this chart. Okay? With regressions like these, you pick the x value. You can pick it. Folks, what you're really doing is if this is your x and y axis, you're coming up with some of the points that would be on this cubic regression. And the calculator will do the rest. Okay? You need a minimum of 4 points. So I'm going to go with 1, 2, 3, 4. That's what I'm going to do. And so the length, therefore, I'm going to write down what I did here. The length is 40 minus 2x. Let's write that down here. The width is 50 minus 2x. And the volume is just multiplying height, length, and width, right? That's length times width times height. That's how you get your volume. And so 40 minus 2x, this would be 38. 40 minus 2x, this would be, you're with me, right? 36, because this is 40 minus 2 times 2, right? That's 36. This is 40 minus 2 times 3, which is 34. And this is 32. So I kind of focus on getting all the lengths in terms of the heights that I just picked. You could have picked 10, 20, 30, 40 if you wanted to. You could have picked 1.5, 2.5, 3.5, whatever you want. You can do that, right? The width is 15 minus 2x, right? So it's 15 minus 2, that's 13. 15 minus 4 is 11. 15 minus 6 is 9. And then 15 minus 8 is 7. That's how I come up with it. And this last one is just 1 times 38 times 13. 2 times 36 times 11. 3 times 34 times 9. 4 times 32 times 7. If you want a more detailed, slower version of this, you watch yesterday's video and you'll be fine. Okay? This is L1 and this is L2. This is just like pretty much all the types that we did in the quadratic world. You usually make one of these your L1 and the last one your L2. It's volume, so we're asked to find the cubic regression. So we're going to go stat, calc, cubic, reg, right? So let's go ahead and do that. You're probably going to have to figure out your window, all of that fun stuff. So 1, 2, 3, 4, and I'm going to go 38 times 13. I'm going to go 2 times 36 times 11, and so forth. You know the drill. Or you don't, because you haven't watched the video, right? But anyways, there's my L1 and L2, these two columns, which means that every single point on the resulting curve is going to be height of the box and the volume, right? Because you chose to put in L1 and L2 like this. If you put L2, one of these other ones L2, it's not going to be a cubic regression. So stat calc cubic regression 1, 2, what was it again? Alpha trace. There we go. And there it is, your cubic regression. Y is equal, don't forget your y equals minus 110x squared plus 600x, and this last piece is 0, right? So we don't worry about that. That's my regression. I'm going to go ahead and graph it. I used my L1, L2, so I'm going to turn on plot 1. I'm going to try zoom 9. Let's see what it does. Not really much help. So I'm going to change my window. I'm going to go -5 here. I'm going to go, I usually go by the biggest size that is there, which is 40, right? That's generally, or maybe a little bit bigger. What I do, -100. I'm going to go 1500 here. Hit graph. I need to go into the negatives, but really the negatives are not, we don't really care about them. It all stops right here when you do a cubic regression regarding volume. It stops right here. That's as far as we go. This, everything else is outside of the domain. So we want to find the relative max or min values. I don't know why the min is there, but anyways, so second trace 4. I'm going to find the max here. Left bound, right bound. It's the exact same as in the video, guys. The max is 3.33. I should have changed the numbers, but I was rushing. I'm rushing when I make these booklets. Like the next one, I hope is gonna be okay in terms of typos, because I really had to push that one. So what is this saying, right? This is saying a height of 3.33 centimeters, right, will result in a maximum volume of 925.93 centimeters, or centimeters cubed, yeah, because of the volume here. But more precisely, cutting out a square with sides 3.33 centimeters will maximize the volume. Like if you cut out 3.3 and 3.3, if these corners measure 3.3 and 3.3, if you cut that out and then fold the box, that would be the box that can hold the most in it, right? And so forth. All right. In terms of test review, I will dig through my pile here, but the booklet is basically everything, right? Everything that can be reviewed is going to be based on the booklet here. So if you haven't done some of the questions, go back, review. If you go through the one thing that you don't have to worry about, are you listening? Remember fencing in grade 11 applied? I'm going to leave that out. And what I'm going to do is, but you're not off the hook. You're not off the hook. What I'm going to do is this. On the test day, I'm going to post a video reviewing it, because technically you've done that in grade 11 applied. And then on Friday, when you come in on Friday, I'm going to throw one AC at you with fencing. And that's going to be it. Like, you don't have to worry about it showing up on the test, but I will AC you on that the next day. Okay, so Friday. I'll remind you again on the test. Yeah.